Hi everybody, this is Mr. Beckstrom and doing another example from section 7.5, and it says find the exact value of the expression. And you notice this is the sine of, and instead of giving us two angles, it gives us two inverse functions here, right? The inverse sine of 0 and the inverse cosine of square root of 3 over 2. So it's kind of giving us a sum formula, but in kind of a weird way. So the first thing I'm going to do is kind of write down the sum formula, which is the sine of two angles. I'll call it A plus B. This sum formula is on page 493, and that's just equal to the sine of A times the cosine of B, plus the cosine of A times the cosine of A times the sine of B times the sine of B. All right. So what can we really do with this thing? Well, the first thing that we kind of have to realize is that, we can do this off to the side here, is that the inverse sine of 0, what that really means is that for some angle, let's say A, that the sine of that angle is equal to 0, right? That the sine of that angle is equal to 0. That's the inverse sine of 0. It's just another way of saying that. So if you took the inverse sine of both sides, you would get this here, that A is equal to the inverse sine of that value there, right? And we can do the same thing for this other angle here, right? We have to call it something different, so we'll just call it B, so it fits in that formula there. So we also have that the cosine of a different angle is going to be equal to the square root of 3 over 2. Square root of 3 over 2, right? So we have 2 out of our 4 parts of this formula. So if we can get the other 2 parts of this formula, then we can kind of fill it in and then evaluate for this entire function. So that's going to be our goal now. We found what the sine of A over here is. That's just equal to 0. We can just plug a 0 in there. And then the cosine of B, we've got what that is right now. That's just going to be the square root of 3 over 2. So we somehow need to find out what the cosine of A is, and we need to also find out what the sine of B is. So that's where we're going to use the Pythagorean identity. So we know that, and I'm going to use x for this, so we can kind of keep it slightly ambiguous here. We know that the Pythagorean identity tells us that the cosine squared of x plus the sine squared of x plus the sine squared of x is equal to 1. And therefore, if we subtract and do some square rooting, that we can get, for example, if we solve for sine, we can get that the sine of x, for example, would be equal to plus or minus the square root of 1 minus like the cosine squared of x, right? Cosine squared of x. So we're going to kind of use this idea here in order to get our last 2 terms there, right? So for example, if I want to get cosine of A, I can do that knowing the sine of A, right? Because it's still part of the same angle there, right? This A still belongs to that A there. All right, but I can use this Pythagorean identity here to solve for that. So if I start with the sine of A, right? Excuse me. If I'm looking for the cosine of A, because I want to know what the cosine of A is. So I'm trying to find out what this cosine of A is. Let's just leave out that S. Sometimes it takes a second. All right, oh, there it goes. Cosine of A, then that should just be equal to, according to this cosine identity, that should just be equal to plus or minus the square root of 1 minus, oh, that should be sine, I can't write today, sine squared of a, right? Well, I know what sine of a is. It's just 0. So 0 squared is just 0. And everything's positive here, right? We should be positive. So this should be positive out there. So this is just going to be equal to the square root of 1. The square root of 1 minus 0, which is 1. So this is just 1. So the cosine of a, so sine of a is 0. Cosine of b is square root of 3 over 2. Let's go ahead and put this in square root of 3 over 2. I just figured out that the cosine of a is equal to 1, kind of using this Pythagorean identity, knowing what the sine of a was equal to, squaring it and putting it in here. So the cosine of a is equal to 1. And we should be able to do the same thing. I want to know what the sine of b is equal to. So if I want to find out what the sine of b is equal to, I can just kind of use that same thing, right? And equal to, and it should be the positive version, so I'm going to be that. So that's 1 minus the cosine squared of b, right? Using that Pythagorean identity with the same angle. So this is going to be equal to the square root of 1 minus, that's square root of 3 over 2, so square root of 3 over 2 squared. I'm kind of running out of space here. So that is equal to 1 minus the square root of 3 squared is 3, 2 squared is 4. So that's going to be 1 minus 3/4, which is equal to the square root of 1. Let me just make sure that's right. 1 minus 3/4, which is 1/4, right? And the square root of 1/4 is equal to 1/2. And that's going to be positive since that's positive up there. So this right here is just equal to 1/2. All right. And bam, that's it. So putting all this together, that's going to be 0 plus 1/2 is equal to 1/2. And we are done. All right, I hope that helped. If you have any questions, let me know, and have a great rest of your week. Thanks.